a software engineer at Expo, and today I'm going to talk to you guys about how to host your own over-the-air update service. So on our roadmap, I'm going to tell you a couple stories, and we're going to walk over how we're going to design an over-the-air service from first principles. And I'm going to talk about how to host your own, and we'll go into a couple other nitty-gritties. But first, I want to tell you the story about the Buggy Valley app. And to talk about Buggy Valley, it was inspired by this app called Pillar Valley. Pillar Valley was built from the ground up in React Native on the Expo platform. And the way it works is there's a puck that circles around on the app, and when it touches the pillar, that's when you touch the screen, and that's how you can go on in the game. It's really cool, and it's available for download from the app stores. Pillar Valley was made by my amazing coworker, Evan Bacon. And when Pillar Valley came out, it got a lot of shout-outs on Twitter. People were like, oh my goodness, Pillar Valley is amazing. This is the best app I've ever seen. And I got really inspired by that. I wanted to make an app to rival Pillar Valley. So I spent a really, really long time making my own app. And this is what I ended up with. A lot of people in the React community would know this class of application as the red screen of death. And when I showed people this app, the reception just wasn't as good as Pillar Valley. So I thought, well, maybe to make a great app, the way to do it is to stand on the shoulders of giants. To illustrate my point, a couple years ago, Node.js is a really great open source project, and people decided, hey, let's fork it and make io.js. io.js became super popular and super great that they decided to merge it back into Node.js. So I was thinking, well, here we have this great app, Pillar Valley. How about I fork it and make an even greater app, Buggy Valley? So you might be wondering, how exactly does Buggy Valley work? So I was thinking, well, it worked like a game Double or Nothing. For those of you who are not familiar with the game Double or Nothing, the player starts off with a pot of money, and with each iteration, there's a 50% chance that they'll double their money, and there's also a 50% chance that they'll get nothing, and you lose your money. So how Buggy Valley works is that the user downloads the app, and there's a 50% chance that they'll see Pillar Valley. There's also a 50% chance that they'll see my red screen of death app. So you might be wondering, okay, how do we even implement Buggy Valley? And let me tell you, the implementation for iOS and Android, they're pretty similar. So I'll just stick with the Android implementation. We're going to be digging around in native code. And the first thing we're going to do is we're going to take the red screen of death app, and we're going to take the Pillar Valley app. They're both JavaScript bundles, and we're going to put it onto our file system. We're going to point to these bundles in our red screen path variable and our Pillar Valley path. Next, we're going to generate a random number. If this random number is even, we're going to load the red screen of death app. If this number is odd, we're going to load the Pillar Valley app. So a lot of you might be wondering, okay, that's all well and good, but how does this load app function even work? So let's take a step back and think about how we load a JavaScript bundle using the React Native architecture. So a lot of people will tell you, okay, so in any given React Native app, you've got at least two threads running. You've got the main UI thread and you've got the JavaScript thread. The main UI thread is where your native code runs, and the JavaScript thread is where your JavaScript logic runs, and that's where it takes the bundle and runs it. These two threads communicate by a bridge module. So what happens when we have a JS bundle on the file system is the main UI thread uses the bridge module and says, hey, I want to put this into memory, and this memory will be JS index, so it will be accessible by the JavaScript thread. And that's how the JavaScript thread will be able to take this JS bundle from memory and run it. And that's what you see when you see a React Native app loaded on your phone. All right, so a quick recap. We're wondering how does load app works, and we're taking a bundle file from the file system and loading it using the React Native architecture. So enough about Buggy Valley app. I want to talk to you guys about the story of the glorified curling app. So it all starts with my friend Alice. When I finished the Buggy Valley implementation, I went up to my friend Alice and I said, "Hey Alice, what do you think about my Buggy Valley app?" And she said, "Well, Buggy Valley fits in perfectly with my use case. Your MVP was just what I needed." One small suggestion though. I really don't want to load the Pillar Valley app. I want to load my app, the Alice app. And second of all, I really don't want to load the red screen of death. That seems kind of useless. So I'm going to rename this variable. I'm going to call it the new Alice app. And what it's going to do is I'm going to make a new update and I'm going to upload that JavaScript bundle to your servers. And when that update is ready, I'm going to curl from your servers and I'm going to download my new bundle to the new Alice app. The last thing that I really didn't like about Buggy Valley is it was loading the apps randomly. And that seems kind of useless. What seems more useful is if we load the new Alice app if it's available. And if new Alice app isn't on the file system, let's fall back and load the old Alice app. And now since we've come a long ways, we've gone from a useless Buggy Valley app into something somewhat useful. We're going to call this useful version glorified curl. All right, so let's take a step back and think about how exactly glorified curl would benefit Alice. So if you run any React Native app, let's take a look at what's currently on file system. You've got a JavaScript bundle and you've got native modules. In a traditional update, you'd be replacing the entire binary. When you pull down the entire binary, that means replacing your JavaScript bundle with a new JavaScript bundle, your native modules with the new native modules. And an average binary size on the App Store is about 30 megabytes. So this entire update could be pretty sizable. So let's take a look at updating your app with glorified curl that we wrote with Alice. So in glorified curl, say if you only made a change to your JavaScript bundle, when you put your stuff to the server, it'll be available right away, and you'll update just your new JavaScript bundle. The native modules stay the same. And also notice that this update is available the moment that you push to your server. Users can pull it down right away. All right, so now that we've talked about a glorified curling app and how to make that from first principles, let's talk about designing a more functional over-the-air service. So I took my glorified curling app and I showed it to my friend Bob. And I said, "Hey Bob, what do you think about my glorified curling app?" And he said, "Well, glorified curl fits in perfectly with my use case. Your MVP was just what I needed. But it's not very performant though." All right, let's take another look at glorified curl. In this first line, we're curling the server path and we're curling the JavaScript bundle to disk. But we have no idea whether it was a new change or if we've pulled it before. And JavaScript bundles can be also pretty sizable. And the behavior we want is to load the JavaScript bundle if and only if there's a change available. We don't want to keep pulling the servers and pulling down a JavaScript bundle, finding out that it's already the JavaScript bundle we have. It takes a lot of bandwidth, and that's just a really naive solution. So to tackle this problem, let's take a step back and think about how the web works for a second. So say you're in your browser and you go to a website, you'll get served index.html. It's usually a small file, and it'll declare the use of a bundle.js. And this it points to this big bundle.js, and it's pretty sizable. All right, so let's take a look at how we can apply this to our over-the-air problem. So instead of having an index.js, let's call it an index.json. It'll be a pretty small JSON, and it'll declare the use of a bundle.js. And this bundle.js will also point to a big JavaScript bundle. And let's take it a step further. Instead of calling our JavaScript bundle bundle.js, we'll call it ios-1a2b3c.js. We'll basically base the bundle name off of its MD5 hash. So let's take a look at how this benefits us. We can cache the bundle URL, and instead of pulling the JavaScript bundle, we'll pull index.json. And when we take a look at the bundle URL we get, if we have cached it, then we'll be like, okay, let's not bother downloading it. We never had it changed anyways. And if we don't have it in the cache, then we'll pull down the JavaScript bundle. All right, so given that, let's go over how you'd use an over-the-air service in your app. So say you have a basic React Native app, and you've built it on the Expo platform. So what you can do is we wrote some DevTools GUI, and you can spin it up, and you can press the publish project to expo.io. And this button does what it promises. It uploads your app to the servers, and it configures it for over-the-air updates. Alternatively, you can use the CLI. You can go into your project directory and type publish, and it should do the exact same thing as the GUI. It should just take your app files and upload them to the servers. Right. And a lot of people often ask, well, this over-the-air service, how do I control the bandwidth usage? How often do we even pull the server for updates? And we thought a reasonable behavior was to pull the server whenever the app starts up. But then people wrote in and they were like, well, okay, sure, you pull the server upon app startup, but sometimes I want to update the app every week, or I want to update the app every month, or I have some other condition that I want to update with, or let's not update apps at all. Like, people just had different use cases. So what we did was we wrote an updates module to customize when you'd like to update your app. And you can make your own policies to say when you'd like to pull the servers and whether there would be changes available. All right, so now that we've talked about how a functional over-the-air update service works, let's talk about hosting your own service. And let's take a look at the motivation for this use case in the first place. So when we had an over-the-air service, people wrote into us and they'd be like, hey, I'm in a country where network latency to your CDNs are really high. And what that means is that updates take a really long time. They're rendered pretty much unusable because it takes forever to pull a bundle file, and we just need a better solution. So we said, how about hosting your own app then? We'll have it in our upcoming SDK release. So people were like, okay, well, how do I go about hosting my own app? I've got this basic React Native app, and tell me what to do from here. So we wrote a script. You can run expo export in your project directory to dump your app files to the disk. So what it dumps to disk is something like this. And a lot of these files may look really familiar. So you'll see this index.json and a JavaScript bundle, and you can see it paired for the iOS platform. So if you recall, we were talking earlier about an index.json file pointing to a big JavaScript bundle. So we've got this index.json and JavaScript bundle pair for both the Android platform and the iOS platform. You might also notice that we've got some assets dumped to file, but we'll talk about that stuff later. All right, so now that you've dumped everything to file, you can run git push master, and it'll go on to GitHub. I pushed to GitHub because it offers free static hosting, but really you can host your app from any server. I just used GitHub because it was convenient for me. All right, so now that you've pushed your stuff to GitHub, we're going to go over how you'd build your app binary given you've got your app on GitHub. So what you can do is you can run build iOS in your project directory, and that will basically build an iOS standalone binary. And while you're running this command, you'll pass in a URL to your GitHub. And you can see it's a super long URL path, but really it's just pointing to my index.json. And if we recall earlier, the index.json is that small JSON that points to the big JavaScript bundle. And that is the file that is always served first. All right, so now you've run this build command. When the standalone binary finishes, you can go to our website and you can press the download button. And the download button does what it says. You will basically download your app binary to the file system. All right, so let's talk about how you'd use this in development. So we talked about this index.json being hosted on GitHub. What we can do is we can convert this URL to a QR code. And it'll work like any QR code that you load into the development app. You open up the scan QR code button and you load it in, and you can just see it on the Expo client. Similarly, we can dump all the assets to file, and we can just run a local host over it. Say, for example, I can run localhost at port 8000. I can point to my index.json file, convert it to a QR code, and it works the same way. I can load it into the development app, and same thing. Okay, so now that we've talked about how to host your own service, let's talk about how asset handling works. So say this is what my app looks like. I've installed it on my phone, and I want to make a small change to it after. Let's say I wanted to add another picture, say of a dog. All right, so what I'll do is I'll push my changes to GitHub, and then I'll go back to what I see on my phone. So originally, I have this app with a cat picture. And currently on the file system, I have the cat picture and I have the JavaScript bundle. All right, and here is the GitHub server that I've hosted my app on. So when I finally push my commits to GitHub with the extra dog picture, let's take a look at the files that needs to be served down for this update to work. So in order for this update to work, I need to pull down a new JavaScript bundle, and I need to pull down dog.png. All right, so first things first, we pull down our index.json, and if the URL that it declares is not what's in cache, we'll be good to go, and we'll download the new JavaScript bundle. So we're going to go ahead and do that, and that will get put on the file system. All right, so let's take a look at what exactly is in this JavaScript bundle. When I have the app of the cat and the dog, I do an image source require cat.png and an image source require dog.png. And we have to figure out, okay, given this declaration, how do we pull down dog.png down to the file system? So we currently don't have dog.png in our file system, but we do have it on our servers. But if we look at this image source requires, it looks like these assets are getting fetched from the file system. So what we did to solve this is we wrote a module to overwrite asset resolution. So it looks like we're pulling this from the file system, but we intercept that call. And our module logic that overrides asset resolution sort of goes like this. First, we'll look for the asset in the file system, and if it's not there, we'll simply look for it from the server. All right, so given that logic, let's take a look at how we update our app. So first of all, we figure out, okay, should we pull dog.png down to the file system? Well, dog.png is not on the file system, so let's grab it from the server. So we pull it down from the server, and we cache it for future use. This means that every time the app starts up again, I don't need to pull quinlanj.github.io. It's on my file system, and I don't need to make another network call. All right, and a lot of you guys might be wondering, how come these assets are stored by hash? We've got this asset like 1ECC2, and what's going on there? Because we're requiring these assets by their name, not by their hash. So let's take a look at app packaging, what's going on there. So in my app.js file, I'll declare like a cat.png, and we'll put it through the React Native packager, And what it'll convert it into is this asset object. It'll say, okay, well, really, we're going to convert this requires to some JSON that says the asset name is cat.png, but also, by the way, here's the hash. So remember I told you before that our overriding logic for asset resolution will be look for cat.png in the file system. If it's not there, look for cat.png from the server. Well, actually, the implementation is look for the hash of cat.png, 1ECC2 in the file system. If it's not there, then we look for 1ECC2 from the server. All right, so you might be wondering, okay, this is cool, but how does this benefit me? So say if you had a really inefficient app. Say I have 8 cat pictures. They're all the same cat picture, but I'm doing an image source requires on the differently named files. I'm declaring cat1.png, crazy cat, lime cat, but they all are really copies of the same file. So when we put it through the packager and we run it in production, what ends up happening is these assets are all resolved to the same file on disk, which is the hash of the cat.png 1ECC2. All right, so we've talked about how over-the-air updates work, and I do have a couple of announcements to conclude the talk. So a while ago, we made a web application called Snack. For those of you who've not seen Snack, Snack is like a JS fiddle for React Native apps. So say, for example, I go to the Snack website and I make an app, a text editor shows up, and I make the background color yellow, and I can see it loading on my phone. What I can do is I can type in blue on the text editor, and it can hot reload on my phone. And so that's basically Snack. What Snack is, it's a live coding environment, and we now made it open source. So if you're interested in how this web application works and the mechanics of it, you can check it out at GitHub. All right, so that basically concludes my talk, and thank you for listening.